Here we have an MSI RTX 3090 that came in for repair. Card is not detected. Let's go over what the customer wrote. The customer said, GPU does not power up. Have tried in other PCs as well with no luck. So the card does not power on. That's how the card looks like. The first thing I want to do, like we always do, is quick measurements for a short circuit on the 12 volt lines, on the 5 volt, 1.8 volt, the PEX line. We will start with the 12 volt lines. We have two of them on top here. Meter in diode mode. We can also measure in resistance mode, but diode mode is faster. We do not have a short. 0.47 voltage drop, we do not have a short. If we go further down to our 5 volt line and we measure, we have 0.37 voltage drop, that's good. Now I'm going to switch to resistance mode to measure our 1.8 volt line, which is all the way down on the bottom, right where that notch is. And if we measure, we should have something like 227. We are reading 230. Very good. 230 ohms. Let's measure our PEX line, which is on top, and we should have something like between 4 to 9 ohms. I'm reading 7.1. That's very good. We're gonna measure our PCIe connector 12 volt pad, and we have about 500 ohm resistance. We do not have a short. And finally our 3.3 volt line, I'm reading 25K, which is good. The next thing I'm going to do is quick visual inspection. A lot of times we find faults with video cards because of a broken component, a missing component, a blown component, corrosion. A lot of times. We have countless number of videos going over fixing video cards because of a knocked off component. Before we start the video, I want to give a shout out to our sponsor PCBWay. PCBWay is a China Shenzhen-based PCB manufacturer and printed circuit board assembler with more than a decade in the field of PCB prototype and fabrication. They offer a wide variety of services including 3D printing, CNC machining, sheet metal fabrication, and much more. PCBWay is committed to meeting all your PCB needs. They offer quality, on-time delivery, and competitive pricing. 1 to 2 layer boards starts at $5 with 24 hours turnaround. Get an instant quote by visiting PCBWay.com or click on the link below, and make sure to check them out. Like a while back, we used to get people in that want to fix their iPhone 6s Plus. They attempted to replace the screen and they removed the screen connector with their nail. But in the process, what happened was they pulled a lot of components off the board, components that are very close to the LCD connector. They pulled like 5-6 components by mistake. I have a lot of videos on those also. A long time ago when we used to fix iPhone 6s Plus. Now we only do it for data recovery and not to fix the phone. And data recovery for, let's say, 6s Plus or for any older phone will probably cost 10-20 times more than what the phone cost. If we're gonna invest the time to work on that phone, it's going to be for data recovery and not for the sake of fixing that phone. It's not worth it working on a phone that costs $50. That's the definition of working hard and not smart. So if the phone is $50, the customer expects you to fix it for $10, $20. No. The good thing is here in the US, or at least in California, not a single customer tries to negotiate or argues about price. Not a single customer. The price that we give is a set price. We do not negotiate. If it works out for the customer, that's good. If not, then the customer can think about it and he's welcome to come back at any time. mean, when you are looking at a board under a microscope that has a quality like this, wow, it's impossible to miss anything wrong with that board if there's any physical damage on that board. A lot of you already purchased our NorthridgeFix microscope, but if you have not and you are in the same type of business or you are doing this as a hobby, just log into our site, northridgefix.com, click on shop, add to cart whatever you need. Everything from this amazing NorthridgeFix microscope, awesome quality, the articulating arm, fume extractor, thermal cameras, hot air station, soldering station, original Amtech Flux, braid wick, tweezers, everything, whatever you need. Most of the stuff that we use, the tools that we use to fix devices are items that we sell. We do not just sell tools for the sake of selling, but we believe in those tools and we use them for the most part. So I do not see anything physically wrong with the board. No physical damage anywhere. I'm going a bit too fast, so we do not waste a lot of time, but I do not see anything wrong with the board. Let me plug the card in. And the next step is to measure voltages. Measuring the lines in diode mode and resistance mode passed. But now we want to see if we have the proper voltages. I'm talking about 12 volts, 5 volts, 1.8 volts, and packs mainly. The one that always tends to go faulty is 1.8. 5, very rare. We used to see 5 volt issues on 1080s, and I have a lot of videos on those. If you look here, I have the card connected to a PCIe adapter that's connected to a Dell motherboard. The motherboard will beep 6 times if the card is not detected when the card is powered on. We have our 12 volt cables, the power cables plugged in on top. And all we have to do is power the card on. Okay, I just want to see if we're going to get 6 beeps, which is an indication that the card is not working. It's not being detected. So we do have 6 beeps. Shut off the power supply. Multimeter probes. And we're going to turn the power supply back on. Because what happens is if you keep the power supply on, the card is going to eventually go into safe mode, where it's going to shut off the core so it doesn't cause damage to the card. We do not have the heatsink on. So right now we have 12 volts. We have 12 volts. We have 5 volts. If we measure our 1.8, we have 0 volts. Our 1.8 volt line is reading 0. And PAX is going to read 0. Core is going to read 0. V-core. Memory, 0. So everything is 0 because our 1.8 volt line is 0. We can turn the power supply off, remove the adapter, remove the power cables, and let's take a look at the 1.8 volt area. A closer look to see if there's anything broken here, anything burned, anything corroded. And the circuit I'm mostly interested in for the 1.8 volt line is back of the board. Right here. Specifically this chip. ALMB. Without wasting any time, let's go ahead and remove the chip. I've worked on similar issues before where that chip was the culprit. And we're going to grab that chip from a donor board. I do not have that chip in stock. Fume extractor on. Hot air station on. So we want to be as efficient as possible. And we are taking a guess based on my experience working with similar issues. We did not do any measurements in this area. No circuit diagrams, no board diagrams, just pure experience. That's how I'm able to get through a lot of devices in a short period of time. We have a lot in the queue, and we cannot waste a lot of time on one single device. So I use experience to just move through all those devices quick. Now, if I do see a light at the end of the tunnel, I would spend more time working on that one specific device. But otherwise, no. And just a minute.
Hello, doctor.
Hello, how are you doing?
Good. You do you remember me from a few days ago?
Yeah. Xbox Series X, you wanted to send to, I think, Microsoft?
I mean, I didn't want to.
You know, HDMI, right?
Yeah. Do you do work on flashlights also?
I do not.
EDC 29.
Got
It's
it.
like
Got it.
$109, which is, for what it is, it's a throwaway flashlight because the battery's going to fail.
I need your first and last name.
John,
And your last name? Got
I
it.
think you told me $395 or
$295. $295.
Three. There.
$295. And your email.
CHI. Perfect.
So the next time you receive an email from us, it means the device is ready for pickup.
Sounds good.
And John, I got you all set, man. Let me just count the money, make sure everything is good. And you did not overpay me. 20, 40, 60, 80, 100, 20, 40, 60, 80, 100, 20, 40, 60, 80, 100, and I owe you $5, okay? I'll put it down.
Thank you, man.
Take care, John.
And when you email me, I then just come in during your business hours.
Yeah, I'll tell you what time to come. All right, take care.
Thank you. Well, I mean, I may not be able to come at that time.
You know, usually between 12 to 4, usually. We're gonna tell you Monday through Friday between 12 to 4. All right.
Thank you.
Okay. So that's a perfect example on how customers are when they come into our shop. The guy wanted to pay $395 and I quoted him $295. I told him no, it's $295 and not $395. He paid cash. Xbox Series X HDMI connector replacement. He came in yesterday and he said that he called Microsoft and they said that they will replace the whole thing for him for $300. I told them we charge $295 to replace the HDMI connector. I think it's a better option for you to go with Microsoft because they will give you a warranty. I do not know, maybe 90 days warranty, 1 year warranty on the replacement. Take it. I give it to him so he can go to Microsoft. And today he came in. He said, I want to do it with you. So I do not know what the deal is, but that's how much we charge currently for that Xbox. We have to disassemble it, work on the motherboard, reassemble it. Maybe there's something going on, we have to disassemble it again, maybe go over the job again. It's a process. The whole thing is a process. And I was just mentioning that not a single customer argues about price. They are willing to pay more so we can work on their device. That's what trust does to people. You no longer have to worry about negotiating. You no longer have to worry about talking about price. When there's trust, people will pay more to get you to work on their device. Where did I get that trust from? Social media, YouTube. People see the work, they see how I work on devices, They see the craftsmanship behind the repair. And how I'm very straightforward with the customer. Anti-glare light. We did not have much of a spill because we cleaned the center pads. We just kept a tiny bit of solder in the center. And only one tiny solder ball squeezed out from here. Perfect. All we have to do is try out the card. Right, so we're gonna power on the card and we're gonna measure our 1.8 volt line. I do not have the heatsink connected. Some video cards, they do not power on if the heatsink is not connected, but a lot of them do. What I want to do is press the power button and immediately measure our 1.8 volt line, and look at this. We have 1.8 volts. Wow. Wow. We got it. We fixed our 1.8 volt line. We do have 6 beeps still, but look at this. We do have our 1.8 volt line here. So the chip that we replaced restored our 1.8 volt line. Now the 6 beeps could be because the board is still burning hot, or it could be that maybe we do not have the heatsink on, or it could be that our core is the problem. Right now, let me measure voltages again, quick. Five volts, of course, we have. If we have 1.8, it means we have 5. We have 1.8. PAX is probably not gonna show because the card, it shuts off core and PAX and memory when it overheats. So let me shut off power, turn power on again, and immediately check PAX. And we do not have PAX. We do not have core. So no PAX and no core. No PAX and no core. We could possibly have a core issue. Right now we have all voltages, but not PAX and not core. I want to check the board under a thermal camera. I just want to see if core is coming on, even for a split second or not. Right now, since we had issues with the 1.8 volt line, 1.8 volt is directly connected with the core. Even though the resistance is measuring good on the line, we may still have issues with the core or memory or both. We do have 12 volts on both lines, 1 and 2. We do have 5 volts. We do have 1.8 volts now. We did not have 1.8 volts before, but our PAX is missing, memory and core. And all those are directly related to core / memory. We're gonna turn the card on. 1, 2, and 3. And not a single heat spot on the board. We have 6 beeps. And the GPU did not even flinch. That could be a problem. That could be a core related problem. No heat spot on the core at all. So it's not a heatsink issue. But I am gonna ask Big Boss to reassemble the card, put the heatsink on and try it again. But I highly doubt it's a heatsink issue. The core is not even heating up, not a single bit. So we're gonna end the video right here. If you have any suggestions, any comments, leave it down below. And if anything comes up, I'll most likely do a part 2. But for now, we're gonna end the video. I hope you enjoyed it. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe. And we'll do something else in the next video.